Have you ever looked up at the night sky and felt a sense of pure wonder? You see the endless ocean of stars, the soft glow of the Milky Way, and the occasional streak of a shooting star, and you can't help but feel that you are part of something incredibly vast and beautiful. The universe is usually a place of quiet, slow, and majestic change. The stars seem fixed in their patterns, the planets follow their predictable paths, and our own world feels stable and solid beneath our feet. But every now and then, the universe decides to put on a show. Every now and then, a series of incredible events happen all at once, reminding us that we live in a dynamic, active, and sometimes violent cosmos. We are living through one of those times right now. It's like being a detective who walks into a room and finds 4 incredible clues all at once: an open window, a mysterious footprint, a strange sound, and a flickering light. On their own, each clue is interesting, but together they tell a story. Right now, the universe has given us 4 incredible clues, and our job is to see how they might fit together into a single, amazing cosmic story. This guide will be our detective's notebook. We are going to take a very long, very detailed walk through each of these cosmic events. We will not rush. We will explain every single piece of the puzzle in the simplest terms possible, using stories and analogies to make sense of it all. You don't need a telescope or a degree in science, just a curious mind. Our story has 4 main characters, each one a superstar in its own right. The ghost stars that roar to life. In the far-off depths of our galaxy, 2 stars that were once quiet and invisible have suddenly burst into brilliant light. These are not new stars being born, but ancient zombie stars that have come back to life in a spectacular fiery explosion. We will investigate the incredible science behind these events, called novae. The restless planet. While the heavens have been putting on a light show, our own planet Earth has been restless. 2 powerful earthquakes recently shook the nation of Venezuela in quick succession. We will explore the tremendous forces that cause earthquakes and dive deep into a fascinating and controversial new idea that suggests a link between these earthly tremors and the weather coming from our sun. The alien messenger. This is perhaps the most mysterious character in our story. A visitor from a completely different star system. An object named 3I ATLAS is currently passing through our solar system. It is acting in ways we have never seen before, breaking all the rules we thought comets should follow. To make things even more exciting, our sun just blasted this alien object with a giant storm of energy. We will unpack every clue about this enigmatic traveler. The fiery heart of our story. At the center of everything, both literally and figuratively, is our sun. The sun is not the calm, steady ball of light it often seems to be. It is a churning, active, and powerful star, and its behavior is the engine driving many of the other events we are seeing. We will get to know our star and understand why it's so energetic right now. The central theme of our investigation is interconnection. Are these separate, random events? Or are they like the different instruments in a grand orchestra, each playing its own part, but contributing to a single magnificent piece of music? Is it possible that the explosion of a star light years away, the activity of our sun, the shaking of our planet, and the arrival of an alien messenger are all connected in a web of cosmic cause and effect? This will be a long journey, but it will be a simple one. We will leave no stone unturned, but we will explain every step of the way. There will be no tests and no complicated jargon you need to memorize. This is not a lecture, it is a story. The story of a remarkable time in our universe. A story that is happening right now, all around us. So let's begin our cosmic safari and meet our first incredible character. The ghost stars that roar to life, the novae. Part 1.1. Spotting a ghost in a sea of stars, the discovery. Let's start our journey by looking up at the night sky. On a clear night, away from the glare of city lights, the view is breathtaking. You can see thousands of stars, each one a distant sun. Some are bright, some are faint. Some have a bluish tint, others are reddish or yellow. For as long as humanity has existed, we have looked at these stars and seen the same patterns. The constellations, like Orion the Hunter or the Southern Cross, have been our companions for millennia. They are a symbol of permanence, of something that is constant and unchanging.
That's why the sudden appearance of a new star has always been such a profound event. Imagine being a shepherd thousands of years ago, knowing the stars like the back of your hand, and then one night seeing a bright intruder, a star that simply wasn't there before. It would feel like a message from the heavens, a sign that something important was about to happen. This ancient experience happened again just a few days ago, but this time the discovery was made with the help of modern technology. The hero of this part of our story is Dr. John Seach, an amateur astronomer. The word amateur simply means someone who does something for the love of it, not as a job. In astronomy, these amateurs are crucial. Their passion leads them to watch the sky with a dedication that professional astronomers, who often have to book time on giant telescopes months in advance, can't always match. These amateurs are the neighborhood watch for the entire cosmos. Dr. Seach has an observatory, and in it, a telescope that is connected to a very sensitive digital camera. His setup is robotic. All night long, it follows a pre-programmed path, pointing to different sections of the sky, opening the camera's shutter to collect the faint starlight and storing the images on a computer. But the real magic happens next. A clever piece of software takes over. It pulls up a new picture that was just taken, then it pulls up an old picture, a reference photo of that exact same part of the sky from a previous night. The software then lays the new picture on top of the old one and compares them. It's a cosmic game of spot the difference. The program meticulously checks every single one of the thousands of dots of light. Is this dot the same brightness as it was before? Has it moved? Or, the most exciting question of all, is there a dot in the new picture that doesn't exist in the old one? If the software finds a difference, it flags it for Dr. Seach to look at. On September 23rd, the program hit the jackpot, not once but twice, in two different parts of the sky. In the constellations of Centaurus and Sagittarius, the software found a new dot of light. Dr. Seach had discovered two novae in a single night, a truly remarkable achievement. Understanding star brightness. To appreciate what he found, let's talk for a moment about how astronomers measure brightness. They use a system called the magnitude scale. It might seem a little strange at first because the numbers work backwards. The smaller the number, the brighter the object is. A negative number is even brighter. Let's look at some examples to get a feel for it. The Sun, the brightest object we can see, has a magnitude of -27. The full moon is about -13. Venus, the brightest planet, can get to about -4. Sirius, the brightest star in the night sky, is about -1.5. The faintest stars you can possibly see with your own eyes on a perfect dark night are about magnitude +6. Anything with a magnitude number higher than 6 is too faint to see without help from binoculars or a telescope. So let's look at Dr. Seech's discoveries. The nova in Sagittarius was found at magnitude 6.2. This is just on the edge of visibility. With a good pair of binoculars, you could definitely find it, a new little pinpoint of light in the rich star fields of the Milky Way. The nova in Centaurus was the real superstar. It started out at a faint magnitude 10.2, meaning you would need a decent telescope to see it. But then, over the next couple of days, it did something amazing. It got brighter and brighter, and its magnitude number got lower and lower. It climbed all the way to magnitude 5.8. Since 5.8 is a smaller number than 6, this means that the Centauri nova is now officially visible to the naked eye. For anyone in the southern hemisphere, a new star has truly joined the familiar constellations in the sky. To put its change in perspective, the jump from magnitude 10.2 to 5.8 is a brightness increase of about 58 times. It's like a 40-watt bulb suddenly shining as brightly as a 2300-watt bulb. So what are we actually seeing? What is a nova? To answer that, we have to tell the life story of a very peculiar kind of star. Part 1.2. The story of a zombie star. What is a white dwarf? Every star, including our sun, has a life cycle. It is born, it lives for a very long time, and eventually it dies. The way a star dies depends on how big and heavy it is. For stars that are about the size of our sun, the end is a long and beautiful process. A star like our sun spends most of its life, about 10 billion years, fusing hydrogen atoms together in its core to make helium. This process, called nuclear fusion, is what makes stars shine. It's like a gigantic continuous nuclear explosion that is held together by the star's own gravity. When the star starts to run out of hydrogen fuel in its core, it begins to die. The core shrinks and gets hotter, while the outer layers of the star puff up to an enormous size. The star becomes a red giant. After this phase, the outer layers of the red giant drift off into space, creating a beautiful, glowing cloud of gas called a planetary nebula. These are some of the most stunning objects we can see with our telescopes. What's left behind in the center, after the gas cloud has drifted away, is the star's dead core. This core is called a white dwarf. And this is where our story of the nova really begins, because a white dwarf is one of the most extreme objects in the entire universe. Let's use some analogies to understand just how strange a white dwarf is. It's incredibly dense. A white dwarf has squeezed a mass similar to our sun's into a ball that is only about the size of the Earth. Imagine taking a full-size car and crushing it down until it's the size of a tiny sugar cube. The white dwarf has done that to an entire star. A single teaspoon of material from a white dwarf would weigh several tons on Earth. It's a zombie star. A white dwarf is not a living star anymore. It's not performing any nuclear fusion in its core. It's basically a gigantic glowing ember left over from the star's life. It's incredibly hot, but it's only shining because it's releasing its leftover heat. Over billions and billions of years, it will slowly cool down and fade away into a cold, dark object called a black dwarf. So a white dwarf is a dead, super heavy, planet-sized star core. On its own, it's not very exciting, but the universe is a funny place. Most stars are not loners like our sun. More than half of all stars in the galaxy are in binary systems, meaning they have a partner star. The two stars are gravitationally bound to each other, orbiting a common center of mass, like two dancers spinning around each other on a dance floor.
And if our white dwarf zombie star happens to have a normal star as its dance partner, then the stage is set for some incredible fireworks. Part 1.3: The Cosmic Thief and the Swirling Pancake of Doom. Let's picture the scene. We have our tiny, super dense white dwarf, and orbiting it, we have a normal, living star, maybe a star like our Sun, or a slightly larger red giant. Because the white dwarf is so incredibly dense, its gravity is immense. Even though it's small, it's a gravitational powerhouse. The two stars are in a cosmic dance, and each one has its own zone of influence, a sort of gravity bubble around it called a Roche lobe. As long as each star stays inside its own bubble, everything is fine. But sometimes, the normal star can puff up as it gets older. It can expand so much that its outer layers of gas spill outside of its own gravity bubble. When that happens, the gas finds itself in a gravitational tug-of-war, and the tiny white dwarf with its super concentrated gravity wins that tug-of-war. The white dwarf starts to pull the gas away from its partner star. It becomes a cosmic thief, relentlessly siphoning off material from its neighbor. A stream of gas, mostly hydrogen, begins to flow from the normal star toward the white dwarf. This stolen gas doesn't just crash directly onto the white dwarf's surface. Because the whole system is spinning, the gas has momentum. It spirals in toward the white dwarf and flattens out into a disk. This structure is called an accretion disk. Let's spend a moment picturing this accretion disk because it's a wild place. It's a gigantic swirling pancake of super hot gas spinning around the white dwarf at incredible speeds. The friction between the gas particles in the disk heats it up to millions of degrees. It gets so hot that it glows brightly in ultraviolet light and X-rays. Even before the nova explosion happens, these systems are powerful sources of high-energy radiation. Now, we have our zombie star, our white dwarf, surrounded by this swirling, super-hot pancake of stolen gas. The gas at the very inner edge of the disk gets closer and closer to the white dwarf, until finally it can't hold on to its orbit anymore and it falls onto the star's surface. This is not a fast process. It happens over a very long time, from thousands to hundreds of thousands of years. Atom by atom, a thin layer of fresh hydrogen gas, stolen from the companion, begins to build up on the dead surface of the white dwarf. It's like a dusting of snow on a mountain peak, slowly getting deeper and deeper over the centuries. This layer of hydrogen is the fuel for the explosion to come. It's the gunpowder being loaded into the cannon. And as the layer gets deeper, the pressure at the bottom, right on the surface of the white dwarf, begins to build to truly unimaginable levels. Part 1.4: The Grand Detonation, the Nova Explosion. We now have all the ingredients for a nova. We have the super hot surface of the white dwarf, and we have a deepening layer of hydrogen gas being squeezed down on top of it by the white dwarf's immense gravity.
As the hydrogen layer gets thicker, the temperature and pressure at the bottom continue to climb. Eventually, they reach a critical tipping point. The temperature hits about 20 million degrees Celsius. At this incredible temperature, nuclear fusion ignites. The hydrogen atoms at the bottom of the layer start to fuse together to form helium, releasing a tremendous amount of energy. Now, in a normal star like our Sun, if the core gets hotter, it expands. This expansion cools it down, and it creates a stable, self-regulating system. But the gas on the surface of a white dwarf is in a special quantum state called degenerate matter. In this state, the pressure doesn't change when the temperature goes up. This means there is no safety valve. There is nothing to stop the reaction from running out of control. So when fusion ignites in one spot, it releases energy, which heats up the hydrogen next to it, which causes it to ignite.
A chain reaction, a wave of fire, spreads across the entire surface of the star in a matter of seconds. The result is a thermonuclear runaway. The entire layer of stolen hydrogen detonates all at once in a single colossal explosion that is equivalent to a planet-sized hydrogen bomb. Boom! The explosion is so powerful that it blasts all of that accumulated hydrogen gas out into space at speeds of thousands of kilometers per second. This expanding shell of hot, glowing gas is what we see from Earth. The tiny, dim white dwarf suddenly becomes hundreds of thousands or even millions of times brighter than it was before. It blazes in the sky as a new star, a nova. But here is the truly incredible part of this story. This titanic explosion is just a surface event. It's like a thin layer of gasoline burning off the surface of a steel ball. The steel ball itself, the white dwarf, is so dense and massive that it is completely unharmed by the surface explosion. So after the fireworks have faded, which can take weeks or months, the white dwarf is still there, and its companion star is still there. And the white dwarf's immense gravity is still there. So what does it do? It goes right back to what it was doing before, stealing gas from its neighbor. The whole process starts all over again. The accretion disk reforms, the hydrogen layer begins to build up once more, and tens of thousands of years from now, it will explode all over again. This is why some novae are recurrent novae. We have seen them erupt multiple times in human history. This is the incredible story behind the two new lights in our sky. We are witnessing the fiery, violent, and beautiful result of two separate cosmic thefts happening in two different star systems, both reaching their explosive conclusions at the same time. The Restless Planet. The Earthquakes in Venezuela. Part 2.1. The Ground Gives Way. The 1-2 Punch. As we were looking up at the distant, silent explosions in the cosmos, our own planet decided to remind us that it is also a place of incredible power and energy. In the nation of Venezuela, the solid ground that we all take for granted suddenly gave way in a terrifying display of force. It began with a powerful jolt. A magnitude 6.2 earthquake erupted. To understand what that feels like, we have to imagine the different ways the ground moves. The first thing you would feel is a sudden, sharp jolt. This is from the fastest type of earthquake wave, called a P wave. It's like a sonic boom traveling through the rock. A few seconds later, the main shaking would begin. This is from the slower S waves, which move the ground up and down and side to side. This is the violent shaking that causes the most damage, throwing objects from shelves and cracking walls. Finally, you would feel a rolling, swaying motion, like being on a boat in a rough sea. This is from the surface waves, which are the slowest but can last for a long time. This first quake was a major event, strong enough to cause significant damage and widespread panic. But the ordeal was not over. Just 6 hours later, as people were trying to recover from the shock and check on their loved ones, the ground erupted again. This time, it was a magnitude 6.3 earthquake, originating from almost the same spot. Let's talk about those numbers again, but this time, let's think about energy. The magnitude scale is logarithmic, which is a fancy way of saying that for each whole number you go up, the energy released goes up by about 32 times. A magnitude 6 quake releases about the same amount of energy as the atomic bomb that was dropped on Hiroshima. A magnitude 7 quake releases the energy of about 32 Hiroshima bombs. A magnitude 8 quake releases the energy of about 1,000 Hiroshima bombs.
The difference between the two Venezuelan quakes, from 6.2 to 6.3, might not sound like much, but the 6.3 quake actually released about 40% more energy than the 6.2 quake. It was like following up a powerful punch with an even stronger one.
This is what geologists call a doublet earthquake, a 1-2 punch that can be particularly destructive. These earthquakes were the most powerful to happen anywhere on Earth since a massive magnitude 7.8 quake had struck off the coast of Russia about a week before. They were a stark reminder that the Earth is a living, breathing, and constantly moving planet. To understand why these quakes happened and to explore a potential mysterious link to space, we first need to take a journey to the center of the Earth. Part 2.2: Earth's Cracked Shell, a simple guide to plate tectonics. If you could hold the Earth in your hands, it might look like a smooth blue marble. But if you could peel back the oceans and the atmosphere, you would see that its surface is not one solid piece. It's a giant cracked puzzle. Let's go back to our analogy of the Earth as a hard-boiled egg. The thin, brittle outer shell of the egg is like the Earth's crust. And this shell is broken into about a dozen giant interlocking pieces. These pieces are called tectonic plates. These plates are enormous. Some, like the vast Pacific plate, are big enough to hold an entire ocean. Others, like the North American plate, carry a whole continent on their back. These plates are not sitting still. They are floating on top of a layer of the Earth's interior called the mantle. The mantle isn't a liquid, but it's so hot that it behaves like a very, very thick, slow-moving tar. And because of the heat rising from the Earth's core, this mantle is slowly churning and moving, and it drags the tectonic plates along with it. The plates move incredibly slowly, only a few centimeters per year, which is about the same speed that your fingernails grow. But over the vast expanse of geological time, this slow, relentless movement is the most powerful force on our planet. It has built the towering Himalayas, carved out the Grand Canyon, and shaped all the continents and oceans we see today. The real action, the source of almost all the world's earthquakes and volcanoes, happens at the plate boundaries, the edges where these giant plates meet. There are three main ways the plates can interact at these boundaries. They can pull apart. This happens at divergent boundaries, where new crust is formed. The Mid-Atlantic Ridge is a place where this is happening. They can collide. At convergent boundaries, one plate can slide under another, a process that builds mountains and creates powerful volcanoes. They can grind past each other sideways. This is called a transform boundary. The famous San Andreas Fault in California is one of these. This sideways grinding is the cause of many of the world's most destructive earthquakes. Now imagine two pieces of rock the size of continents with rough, jagged edges trying to slide past each other. They don't just glide smoothly, they get snagged and stuck on each other. But the immense forces driving the plates from below don't stop. They continue to push. So for years, decades, or even centuries, the plates remain stuck, but the stress along the fault line builds up. It's like trying to push a very heavy refrigerator across a sticky floor. It sticks, so you have to push harder and harder. The energy you are using is being stored up in the friction between the refrigerator and the floor. An earthquake is the moment of release. The stress along the fault finally becomes greater than the friction holding the rocks together. With a sudden violent snap, the rocks break and the plates lurch forward, sometimes by several meters in the matter of seconds. All of that stored up energy is released in the form of seismic waves that travel through the earth and shake the surface. That sudden violent snap is the earthquake.
The country of Venezuela is located in one of these very active zones. It sits right on the boundary between the South American plate and the smaller Caribbean plate. These two plates are grinding past each other sideways, making the entire region a geological hotspot, prone to frequent and powerful earthquakes. The two quakes that just happened were a classic example of this relentless tectonic pressure reaching its breaking point. Part 2.3, A Whisper from the Sun, the controversial space-weather connection. We now have a perfectly good earthly explanation for the earthquakes in Venezuela. They were caused by the grinding of tectonic plates. So why would we even consider a connection to outer space? This is where our cosmic detective story takes a very interesting and very speculative turn. This is a journey to the cutting edge of science, where new and unproven ideas are being explored. A few days before the Venezuelan quakes, a group of independent researchers who monitor space weather issued a public earthquake watch. They didn't predict the exact location or time, but they said that the conditions were ripe for a major earthquake to occur somewhere on the planet in the coming days. The fact that two major quakes then happened right in the middle of their watch period is, at the very least, a remarkable coincidence. Their watch was not based on geology. It was based entirely on the behavior of the solar wind. As we've learned, the solar wind is a constant stream of particles flowing out from the sun. It's the sun's breath, washing over our planet every second of every day. And these researchers have noticed a pattern. It seems that many of the world's largest earthquakes have been preceded by a very specific and unusual disturbance in the solar wind. Let's break down this pattern in slow motion. The fire hose from the sun. Sometimes an area on the sun called a coronal hole opens up. You can think of this as a temporary hole in the sun's magnetic field that allows the solar wind to blast out like water from a fire hose, much faster and more powerfully than usual. The cosmic traffic jam. As this super-fast stream of solar wind travels towards Earth, it catches up to the slower solar wind that left the sun earlier. This creates a kind of cosmic traffic jam. The fast wind slams into the back of the slow wind, creating a shock wave and a region of very dense, compressed solar wind. This is called a co-rotating interaction region, or CIR. The eerie calm. When this whole structure sweeps past our planet, Earth first gets hit by the dense, compressed traffic jam. The pressure on our planet's magnetic field goes way up. But then right after that dense part passes, we enter the fast stream itself. And this stream, while fast, is often very, very thin. The density of the solar wind particles drops to an unusually low level. It's like being hit by a powerful gust of wind, which is then immediately followed by an eerie, almost empty calm. So the pattern is a dense blast followed by a strange low-density patch. This exact pattern was observed in the days leading up to the Venezuelan quakes. This is what triggered the earthquake watch. But how on earth could this possibly be connected to the movement of rocks deep underground? The hypothesis, the final straw. This is where we get to the core of this new and controversial idea. The proponents of this theory do not believe that the solar wind causes earthquakes. The energy from the sun is nowhere near powerful enough to move tectonic plates. Instead, they believe it might be a trigger. Let's go back to our analogy of the heavy refrigerator stuck on a sticky floor. You are pushing it with all your might. The pressure is immense. It's just on the verge of sliding. It is at its breaking point. At that exact moment,
Imagine a friend comes along and gives the refrigerator a tiny, gentle tap on the side. That tiny tap doesn't have enough energy to move the fridge on its own, but because the fridge was already under so much stress, that tiny tap is the final straw, the tiny nudge it needed to break the friction and lurch forward. The theory is that the strange solar wind event might be that tiny, gentle tap for our planet's tectonic plates. The idea is that the sudden change in the plasma pressure around our planet, the dense blast followed by the empty patch, could create a tiny disturbance in the Earth's magnetic field and even its crust. This cosmic jiggle is incredibly small, far too small to be felt or to cause any damage on its own. But if a fault line, like the one in Venezuela, is already stressed to its absolute limit, coiled like a spring and ready to snap, then this tiny cosmic jiggle from the solar wind could be the final straw. It could be the trigger that causes the fault to finally let go. Why is this idea so controversial?
Most mainstream geologists and physicists are very skeptical of this idea. They rightly point out that the forces inside the Earth are millions of times more powerful than the forces from the solar wind. They argue that comparing the two is like comparing the force of a feather to the force of a freight train. From their perspective, the connection is just a coincidence. And they may be right. The study of this potential link is very new, and there is not yet a well-understood physical mechanism that can definitively connect the solar wind to the Earth's crust. However, the researchers who study this pattern have compiled a list of dozens of major earthquakes that have followed this exact same solar wind signature. To them, there are too many of these coincidences to ignore. The Venezuelan earthquakes are another compelling entry in their cosmic detective notebook. It's a tantalizing clue that suggests the relationship between the Sun and the Earth might be far more complex and mysterious than we currently understand. Part 3.1 A Visitor from the Great Unknown. What does interstellar mean? Of all the incredible things happening in our cosmic neighborhood right now, this is the one that is capturing the imagination of people around the world. We have a visitor, and this visitor is not from around here. It is a true alien in the most literal sense of the word. It has come from the vast dark emptiness between the stars. Its name is 3I/ATLAS. To truly grasp how special this is, let's first think about the boundaries of our own solar system. We are used to thinking of our solar system as the Sun and the 8 planets, but it's much, much bigger than that. Far beyond the orbit of Neptune, there is a gigantic spherical cloud of trillions of icy objects that surrounds our entire solar system. This is called the Oort cloud. Think of the Oort cloud as a giant icy bubble that marks the edge of our Sun's gravitational influence. The comets that occasionally fall in towards the Sun from this cloud, the ones we see every few years, are locals. They are part of our home system. The object 3I/ATLAS did not come from our Oort cloud. Scientists know this by tracking its path. It is traveling so incredibly fast that our Sun's gravity cannot capture it. It is on a path that came from deep space, will swing once around our Sun, and then will be flung back out into deep space, never to return. Its path is a clear sign that it is not one of our own. It is an interstellar object, which means it came from between the stars. Let's go back to our analogy of living on an isolated island. The Oort cloud is like the distant fishing grounds that your island's boats sometimes visit. Any boat you see from there is familiar. But 3Eyes/ATLAS is a canoe that has drifted across the entire ocean from another island, another world that you never even knew existed. This is only the third time in history that we have ever confirmed a visitor like this. The first was 1Eye/oumuamua in 2017. The name means scout in Hawaiian. Oumuamua was a complete enigma. It was a small rocky object shaped like a cigar or a flat pancake. Most mysteriously, it was speeding up as it left our solar system, as if something was gently pushing it. Scientists still debate what it was. The second was 2Eye/Borisov in 2019. This one was much more familiar. It looked and acted like one of our own comets, with a fuzzy cloud of gas and a long tail. It was exciting because it suggested that other solar systems might be built from the same stuff as ours. And now we have our third visitor, 3Eye/ATLAS. And it turns out this one is perhaps the strangest of them all. It's not a weird rock like Oumuamua, and it's not a normal comet like Borisov. It's something in between, a true puzzle that is challenging everything we thought we knew. Studying it is a priceless opportunity to learn the secrets of a faraway star system, and this messenger has brought with it a very big mystery. Part 3.2. The comet that breaks all the rules, the case of the two tails. To understand why ATLAS is so incredibly weird, we need to talk about comet tails. They are one of the most beautiful sights in the night sky, and they have a very simple and logical explanation. As we've learned, comets are basically dirty snowballs, a mixture of ice, dust, and rock. When a comet's orbit brings it into the inner solar system, it gets closer to the sun and starts to heat up. The ice on its surface turns directly into gas, a process called sublimation. This gas flows away from the comet, carrying dust particles with it. This forms a fuzzy cloud around the comet's solid core, which is called the coma. This coma is what gets shaped into the comet's tails. There are actually two types of tails, and they are formed by two different forces from the sun. The ion tail or gas tail. The solar wind, that stream of particles from the sun, is very good at pushing away the lightweight gas from the coma. It pushes the gas straight back, directly away from the sun. This gas tail is made of charged particles called ions, and it often glows with a faint blue light. Think of this tail like a windsock at an airport. It always points perfectly straight, showing you exactly which way the wind is blowing. The ion tail always points directly away from the sun. The dust tail, the dust particles that come off the comet, are much heavier than the gas particles. The solar wind isn't strong enough to push them around. Instead, they are gently nudged by the pressure of sunlight itself. This gentle push isn't as strong, so the dust particles tend to lag behind the comet in its orbit. This creates a second tail that is broad, curved, and usually whitish or yellow in color. Think of this tail like the trail of sand you would leave if you were running along a beach on a windy day. The sand gets blown by the wind, but it also follows the path you took, creating a curved trail behind you.
So, a normal comet can have two tails, a straight bluish gas tail and a curved whitish dust tail. But in every single case, both tails point generally away from the sun. Now, let's look at 3Eye-ATLAS, our biggest and best professional telescopes, which can analyze the specific type of light coming from the comet, have taken pictures of it. They see a classic gas tail behaving exactly as it should, pointing straight away from the sun. But here is the mind-bending mystery. Amateur astronomers all over the world, with their own powerful telescopes, have been taking beautiful, long-exposure photos of Atlas. And their photos are showing something else entirely. They are showing a second, very bright plume of material that is pointing in the completely opposite direction. It seems to be pointing towards the sun. This is, to put it mildly, completely bonkers. It should be impossible. It breaks all the known rules of cometary physics. It's like sticking your head out of a moving car window and having your hair blow forward into your eyes. It defies logic. The entire astronomical community is buzzing with this puzzle. What could possibly be causing it? They have a few ideas, but none of them are perfect. Is it an optical illusion? There is a phenomenon called an anti-tail. It can sometimes happen when Earth passes through the plane of a comet's orbit. From our specific vantage point, some of the heavier dust particles in the curved dust tail can look like they are pointing towards the sun. This is the most likely normal explanation, but the forward tail on Atlas seems brighter and sharper than a typical anti-tail. Is it shooting out a powerful jet? Comets are not smooth snowballs. Their surfaces are lumpy and cracked. It's possible that there is a big crack or vent on the surface of Atlas that is shooting out a powerful jet of gas and dust, like a geyser. If the comet is spinning in just the right way, this jet could be aimed mostly towards the sun. Did it break up? Another idea is that a large chunk of Atlas might have broken off recently. This chunk would be traveling on a very similar path just ahead of the main body, and the sunlight reflecting off it could look like a forward-facing tail. Right now, nobody knows the answer. This interstellar messenger is not just carrying secrets from its old home, it's creating brand new mysteries right here in ours. And just as scientists were trying to solve the mystery of the two tails, the sun decided to throw another major clue into the mix. Part 3.3: Ambushed by a Solar Tsunami, the CME Impact. As we have discussed, our sun is currently in the active phase of its 11-year cycle. This means its surface is a churning, magnetically chaotic place, prone to large and violent eruptions. A few days ago, one such eruption occurred. A tangled region of magnetism on the sun's surface snapped like a giant rubber band, launching a colossal cloud of plasma and magnetic energy out into space. This is a coronal mass ejection, or CME. Let's spend some more time with this idea because it's at the heart of our story. The size. A typical CME is enormous. By the time it reaches Earth, the cloud of gas can be millions of kilometers wide. The weight. Even though the gas is very thin, the cloud is so huge that it can contain 1 billion tons of material. That's the weight of a mountain moving through space. The speed. CMEs travel at incredible speeds, from a few hundred to over 2,000 kilometers per second. That's millions of miles per hour. A fast CME can travel from the sun to the Earth in less than a day. The power. A CME is not just a cloud of gas. It is threaded with powerful magnetic fields. It is a giant traveling magnetic storm. And the CME that erupted from the sun a few days ago was aimed like a cosmic cannonball directly at our mysterious interstellar visitor 3I-Atlas. NASA's space weather models, which are like weather forecasts for the whole solar system, predicted the impact with high accuracy. It was a guaranteed head-on collision. This event is a dream come true for planetary scientists. It is a perfect natural experiment. You have a completely unknown object, and you are about to hit it with a massive blast of energy. The way the object reacts to this impact will tell you an enormous amount about its nature. Let's go back to our analogy of finding a strange sealed box on the beach. You don't know what it's made of or what's inside, so you decide to perform some tests. First, you tap it gently. This is like the normal solar wind hitting Atlas. Then you decide to hit it with a hammer. This is the CME impact. The results of the hammer blow will tell you a lot.
If the box makes a loud ringing sound, it might be made of metal. If it makes a dull thud, it might be made of wood. If it shatters into 1,000,000 pieces, it was probably very fragile. If it starts glowing, it must have something very strange inside. Scientists all over the world are now using their telescopes as ears to listen to the results of this cosmic hammer blow on 3I-ATLS. They are watching for any changes, no matter how small. A change in brightness. The extra energy from the CME could cause a huge amount of ice on Atlas's surface to vaporize all at once, making its coma much bigger and brighter. It could flare up, becoming many times brighter than it was before. A change in the tails. The powerful magnetic field of the CME could have a dramatic effect on Atlas's tails. It could literally rip the normal gas tail right off, an event called a disconnection. And what will it do to the mysterious forward-facing tail? Will it make it brighter? Weaker? Will it change its shape? The answer will be a major clue to solving its mystery. A change in its structure. Is it possible that the CME impact was so violent that it physically damaged this alien object? Could it have triggered cracks or even caused the whole thing to break apart into smaller pieces? The answers to these questions will be coming in over the next few days and weeks as scientists analyze all the data. This solar storm has turned our mystery visitor into a live, unfolding science experiment on a scale we could never have created ourselves. Part 3.4, A Date with Destiny, The Visitor's Dangerous Journey Ahead. The drama for 3I-ATLS is far from over. In fact, its most dangerous and revealing moments are still ahead of it. It has a very busy travel itinerary over the next month, and each stop will be a new opportunity for discovery. October 3rd, the Mars Encounter. Atlas is scheduled to make a very close flyby of the planet Mars. It will pass at a distance of less than 0.2 astronomical units, which is less than a fifth of the distance between the Earth and the Sun. This is exciting because we don't just have telescopes on Earth, we have robotic scientific probes orbiting Mars. Spacecraft like NASA's Mars Reconnaissance Orbiter and ESA's Mars Express could potentially turn their cameras and sensors towards Atlas as it flies by. This would give us a completely different view of the object from a much closer perspective without the blurring effect of Earth's atmosphere. October 21st, a trip behind the Sun. On this date, Atlas will be at a point in its orbit called superior conjunction. This means that from our perspective on Earth, it will be on the exact opposite side of the Sun. For a while, it will be lost in the Sun's blinding glare, making it very difficult for normal telescopes to see. However, we have special solar observatories, like SOHO spacecraft, that are designed to stare at the Sun's outer atmosphere. It's possible that these solar telescopes might catch a glimpse of Atlas as it passes through their field of view. October 29th, the Trial by Fire. This is the climax of the story. On this day, Atlas will reach perihelion, the point in its orbit where it is closest to the Sun. This is the moment of maximum danger and maximum stress for any comet. Let's imagine what Atlas will experience at perihelion. The heat, the intensity of the sunlight will be incredible, far stronger than anything it has experienced before.
The surface of Atlas will be roasted, causing its ices to vaporize at a furious rate. It will likely become more active and brighter than ever before. The gravity. The sun's immense gravitational pull will be tugging on it with incredible force. The side of Atlas facing the sun will be pulled much more strongly than the side facing away. This difference in pull, called tidal force, can literally tear a comet apart. Many comets in history have met their end at perihelion. A famous example was Comet Ison in 2013, which was expected to put on a spectacular show, but instead completely disintegrated as it whipped around the sun. Will 3I-ATLS survive its perihelion? Or will this mysterious messenger from another star be destroyed by the power of our own sun? If it survives, it will tell us that it is a strong, solid object. If it breaks apart, studying the pieces will give us an unprecedented look at the interior of an object that was formed in another solar system. Either way, the next month promises to be one of the most exciting periods in modern astronomy. The story of 3I-ATLS is a gift from the cosmos, a mystery that is unfolding right before our very eyes.
The fiery heart of our story, the active sun. Part 4.1. The sun's great 11-year mood swing. We've mentioned the sun's solar wind, its coronal holes, and its giant energy burps called CMEs. It's clear that the sun is a very active place. But it's not always this way. Our sun has a personality that changes over time, a rhythm that beats roughly every 11 years. This is the famous solar cycle. Think of the sun's cycle like the changing of the seasons on Earth. Sometimes it's calm and quiet, and other times it's stormy and active. Solar minimum. This is the sun's winter. It's a period of calm. The sun's surface is smooth and almost completely free of sunspots. It produces very few solar flares and CMEs. The solar wind is weaker and slower. Solar maximum. This is the sun's summer. It's a period of intense activity and storms. The sun's surface is covered in dark patches called sunspots. It erupts frequently with powerful solar flares and CMEs. Right now, we are in the middle of a solar maximum. The sun is at the peak of its stormy season, which is why we are seeing all of this activity that is affecting our story. But what is actually causing this 11-year cycle? The answer lies deep inside the sun, and it has to do with magnetism. The sun is not a solid ball of rock like the Earth. It's a giant ball of super hot gas called plasma. And because it's not solid, it doesn't rotate all in one piece. The sun's equator spins much faster, about once every 25 days, than its poles, which take about 35 days to make one rotation. This is called differential rotation. Now, the sun has a powerful magnetic field, much like the Earth does. You can imagine the magnetic field lines as giant rubber bands that loop through the sun's interior, from its north pole to its south pole. At the start of a new cycle, solar minimum, these magnetic rubber bands are neat and orderly. But because the sun's equator is spinning faster than its poles, it starts to drag the magnetic field lines along with it. The magnetic rubber bands get stretched and twisted. Over several years, as the cycle builds up towards solar maximum, these magnetic field lines become incredibly tangled and knotted up like a giant mesh of yarn. Eventually, these tangled knots of magnetism become so intense that they burst through the sun's surface. These places where the tangled magnetic fields burst through the surface is what we see as sunspots.
A sunspot looks dark because it's slightly cooler than the area around it. The intense magnetism is preventing the hot gas from below from rising to the surface. But don't be fooled by their dark appearance. Sunspots are cauldrons of magnetic energy. They are often many times larger than the entire planet Earth. These tangled magnetic fields are storing up a huge amount of energy. Eventually, the magnetic rubber bands can get so twisted that they snap and reconfigure themselves into a simpler shape. When they snap, they release all of their stored energy in a massive, violent explosion. If this explosion is a flash of light and radiation, we call it a solar flare. If it also throws a giant bubble of gas and magnetism out into space, we call it a CME. This is why solar maximum is the stormy season. The sun is covered in these magnetically tangled sunspots, each one a cauldron of magnetic energy, ready to fire off a flare or a CME. After a few years of this intense activity, the sun's magnetic field manages to untangle itself. The number of sunspots begins to decline, and the sun enters its quiet solar minimum phase again. The entire cycle, from one minimum to the next, takes about 11 years to complete. Our current solar maximum is proving to be even stronger than scientists initially predicted, meaning our sun is in a particularly energetic and stormy mood right now. Part 4.2 – Earth's Cracked Shield and the Season for Storms. So we have an active sun that is throwing more solar storms our way. This has a direct effect on us here on Earth. And just like on Earth, where hurricane season happens at a certain time of year, there is also a geomagnetic storm season for our planet.
First, let's talk about our planet's primary defense against the solar wind, our magnetic field, also known as the magnetosphere. You can think of it as an invisible shield that surrounds our planet. It's generated by the churning, liquid iron core deep inside the Earth. This shield extends tens of thousands of kilometers out into space, and its job is to deflect the constant flow of charged particles from the sun. Without it, the solar wind would strip away our atmosphere, and life on Earth would be impossible. This shield is very good at its job, but it's not perfect. Sometimes, a lot of energy from the sun can get through and cause a disturbance in the shield. This disturbance is called a geomagnetic storm. These storms are what cause the beautiful auroras, but they can also have negative effects, like disrupting satellite communications and power grids. Whether or not a solar storm can get through our shield depends a lot on the direction of the magnetic field that is embedded in the solar wind. Let's use a simple analogy with bar magnets. The Earth's magnetic shield has a north pole pointing upwards, geographically north. The solar wind's magnetic field can point in any direction. If the solar wind's magnetic field is also pointing north when it arrives at Earth, it will be aligned with our shield. The two magnetic fields will repel each other, and our shield will remain strong. But if the solar wind's magnetic field is pointing south, it will be pointing in the opposite direction to our shield. When these oppositely aligned magnetic fields touch, they can do something called magnetic reconnection. Think of two zippers. If you try to mesh them together the wrong way, nothing happens. But if you align them correctly, they can zip together. Magnetic reconnection is like unzipping the sun's magnetic field and our Earth's magnetic field, and then re-zipping them together in a new configuration. This process opens a giant door in our magnetic shield, allowing a flood of energy and particles from the solar wind to pour directly into our upper atmosphere. This is what triggers the strongest geomagnetic storms. So the key ingredient for a big storm is a solar wind with a strong, southward-pointing magnetic field. And here's the final piece of our puzzle. It turns out that because of the way the Earth is tilted on its axis as it orbits the sun, there are 2 times of the year when the geometry is absolutely perfect for us to encounter this storm-triggering southward magnetic field. These 2 times are the spring and the fall.
specifically around the equinoxes in March and September-October. This well-known phenomenon is called the Russell-McFerrin effect. Let's go back to our analogy of the house with a window. Our magnetic shield is the house. For most of the year, the window that lets in solar energy is mostly closed. But in the spring and the fall, the tilt of the Earth is just right that this window is cracked open much more often. This means that during these two seasons, our planet's natural defenses against solar storms are a little bit lower. The very same CME that might only cause a minor disturbance if it hit us in December or July could cause a major, powerful geomagnetic storm if it hits us in October. And that is exactly the situation we are in right now. We have an active sun at solar maximum, which is producing more and more powerful solar storms. And we are entering the fall season, the time of year when our planet's magnetic shield is naturally more susceptible to these storms. This perfect combination for a very active period of space weather. This increases the chances of seeing more powerful auroras, but it also means our satellites and power grids will be on high alert. This storm season is the backdrop against which all the other events in our story are unfolding, adding another layer of energy and dynamism to an already incredible time in our solar system. Grand conclusion, a universe of beautiful and mysterious connections. We've come to the end of our long and detailed journey. We have traveled together from the fiery hearts of distant exploding stars to the churning, molten core of our own planet. We have followed the path of a mysterious alien messenger, and we have stared into the stormy face of our sun. We set out as cosmic detectives, and now it's time to look at all the clues we have gathered and see what story they tell. So what have we learned? We've learned that two ghost stars have roared to life in our night sky. We discovered that these are not new stars at all, but ancient dead zombie stars called white dwarfs. In a dramatic act of cosmic thievery, they stole gas from a nearby companion star, and after thousands of years of buildup, this stolen material detonated in a spectacular surface explosion, a nova, making them shine with a brilliant temporary light. We've learned that our restless planet trembled with a powerful pair of earthquakes in Venezuela. We explored the immense tectonic forces that are constantly shaping our world and dove deep into a tantalizing, controversial new theory that suggests these earthly tremors might be triggered by a cosmic jiggle from the sun's solar wind, a whisper from space that can shake the ground. We've learned that we have an incredible alien messenger, 3I ATLAS. This visitor from another solar system is a complete enigma, a comet that breaks all the rules with its mysterious forward-facing tail. We learned that it was just ambushed by a giant solar tsunami, a CME, and we are all waiting on the edge of our seats to see how it will react as it heads for its dangerous, fiery date with destiny close to our sun. And finally, we've learned that the fiery heart of our story, our own sun, is the main character tying all of these events together. It is in the stormy season of its 11-year cycle, a solar maximum that is producing the CMEs and the solar wind events that are at the center of our investigation. And we learned that we are entering a special time of year when Earth's own magnetic shield has a few cracks in it, making us more open to the sun's stormy moods.
So, what is the grand story that all of these clues tell us? The story is one of connection. It's a story that teaches us that we are not living on a lonely, isolated rock in a quiet, empty universe. We live in a dynamic, interconnected cosmic ecosystem, a place where everything is tied together in a beautiful and mysterious web of cause and effect. The universe is not a silent, static painting to be admired from afar. It is a living, breathing system, a grand symphony of action and energy. The explosion of a star on the other side of the galaxy sends particles that may, in a very small way, influence the clouds above our heads. The magnetic moods of our sun,
150 million kilometers away might influence the very ground we stand on. And a tiny, lonely traveler from another star, after a journey of millions of years, can arrive in our neighborhood and ignite the curiosity and wonder of billions of people on a small blue planet. We are incredibly fortunate to be alive at a time when we have the tools and the passion to witness this cosmic story unfold in real time. The coming weeks and months, especially as we follow the adventure of 3I-ATLAS, promise to be full of new discoveries, new puzzles, and new wonders. The next time you look up at the daylit sky, remember the incredible stormy power of the star that makes our life possible. And the next time you look up at the vast dark ocean of the night sky, remember that it is not just a collection of quiet twinkling lights. It is an arena of incredible action, profound mystery, and deep connection. And you are a part of it. We all are. We are all part of this grand, unfolding cosmic story.